Hi, good evening, class. Tonight we'll be going over chapters 9 and 10, measurements and priorities, respectively. So, talking about measurements, the important thing about measurements is it allows you to understand when your product or when your requirement has been delivered, has been developed, has been tested, letting you know it closes that loop and helps you to identify that you've gotten what you've asked for. So we're going to be answering the questions of how will you know that this requirement has been met satisfactorily? How can you measure delivery of what is required? And how will you tell that the product or delivery does what it says? And how do you know that your suppliers have done what you've asked them to do? So now, this is really a function of, it's basically a flow, a process flow from writing good requirements, providing the acceptance test criteria or acceptance criteria, and then doing the testing so you can validate that. And of course the development is the piece that delivers this. Now tonight we'll be talking about the acceptance criteria. We will not be talking about the quality of service. Quality of service is not really something that we talk about in software development. It is something that is more in the nature of product development. Now there are a lot of software packages that provide quality of service, but that's really not a notion that we discuss in software development. Hence, pages 223 through 232 will not be covered on any exam. So if you have read that, it's good. You've enlightened yourself a bit. However, you're not responsible for it on the test. So let's talk about acceptance criteria. Acceptance criteria is what makes requirements measurable. Acceptance criteria provides the guidance for testing the happy path. The happy path, remember, is really the outcome that the customer is looking for. And the acceptance criteria also provides a contract for the user acceptance. If you're the customer, you're going to say, this is what I want, and that gets documented, but you know the meaning sometimes can be ambiguous. So we have this thing called acceptance criteria that says as long as we provide this, then you will accept it, and you have to agree to what this is. You have to agree as a customer to the acceptance criteria. And we'll get into an example of some good acceptance criteria here in a few slides. Okay, let's talk about what I call the function. And the function is a well-written functional requirement, allows for the acceptance criteria to be easily written. So if I were to say, you know, let's talk about a car. If I were to say a car shall have 4 doors, okay, that's a requirement. Therefore, the acceptance criteria is the car has 4 doors, 2 on each side. So when I get to the testing, I can test that, and when I get to the as the customer, I can look at that and say, yeah, it's got 4 doors, 2 on each side. That's my acceptance criteria. Therefore, I accept that requirement as being delivered. Now that's obviously a very easy example. However, this is really acceptance criteria is easy, and it can be easily defined as long as the functional requirement is well written. Now, defining the acceptance criteria will also aid in clarifying the functional requirement, because remember I just said a minute ago that the requirements can sometimes be nebulous. And I've got a video that we're going to watch in a few minutes talking about how text can be ambiguous. Well, the acceptance criteria can help clarify some of those functional requirements and some of what is intended. So now in Agile, we use these guidelines called INVEST for identifying and qualifying what is a good requirement. So, it's a fair question to say, how do I know that my requirements are good requirements, especially when you're a new business analyst, especially when maybe you're operating in a new domain space and you're really trying to understand, I understand the requirement, but I don't know if this is a good requirement. So using this acronym called INVEST, like I said, we use it in Agile. We first start out with a requirement should be independent, meaning that it has no dependency on a requirement that comes after it. Now, if you remember in Agile, we develop things in sprints, a sprint being 1 week, 2 week, 3 weeks, or 4 weeks. And so when we develop something, we want to be able to put it into production. What we don't want to do is develop a piece of functionality only to have it sit on the shelf waiting for something else to be developed. That would be a dependency, and we want to stay away from that. And a lot of that has to do with priorities, and we'll get into that in next chapter as well, meaning in the order that you prioritize them. Another one is negotiable. Now this goes back to the notion of focusing on the what, not the how, so that when a customer says, well, the product owner says, I want a car with 4 doors, then the developer gets to identify how he's going to deliver that 4-door car. That keeps it negotiable, as long as the product owner or the customer says that it meets his acceptance criteria. The requirement needs to be valuable. Now this seems almost comical. Why would we build something that wasn't valuable? Well, you'd be surprised when you get into these very complex products and software projects that a lot of requirements will make their way into the product that are not valuable. And when I mean valuable, meaning that they do not provide value to the business. Now there is something that we call in Agile. It's called minimal marketable feature, and this is not unique to Agile. It's really just good practice wherever you go. Minimal marketable feature means what is the minimum that I can build to meet the requirement. Because if you build anything more than that, then you're really building in overhead. You're making it more expensive, making it take more time, and possibly delivering some additional complexity that is not necessary. So valuable in one sense means, yes, we're building something that the business wants, that's of value to the business, and that is something that the business says, yes, this is valuable. This also ties into a little bit with priorities. We should not be building low priority items before we're building high priority items. And again, minimal marketable feature, if you want to take a good example of that, if you look at Google's homepage, they really started out and they mastered this concept of minimal marketable feature, that if people want a search engine, let's give them a search engine. Let's not give them ads. Let's not give them news. Let's not give them stock quotes. Other people, other organizations, Yahoo and AOL, they give you all these things with your search engine. Google just wants to give you a search engine. It's a minimal marketable feature. What's the minimum amount of functionality that we can give that will meet the customer's need? And a good piece, a good reason for doing this is it allows you to develop functionality more quickly. It allows you to stay nimble and to stay, this is where one of the reasons that the term agile was used. It keeps you agile, allows you to stay flexible in your requirements. If you start building additional functionality that is nice to have when it's not needed, then what you have is you've introduced complexity. The more complex your software or your functionality, the less nimble it can be. And the next one here is estimable, and basically this kind of gets into the measurements. The requirement has to be something that can be estimated. And again, so you say, you know, that seems a little silly, seems all requirements, you can estimate them. Well, if you look at the requirement of should be easy to use, you cannot estimate that because it's a very subjective request. So we want to make sure that they have measurements, metrics are great, and make sure that we can estimate it. The next one is small. The smaller the requirement, the better. And it's better to have 3 small requirements than 1 big requirement. Again, in Agile, well, let me back up a little bit. So how do you define small? I mean, small, you know, to me might be large to you. And that could go by teams. You could have different size teams. So how do you define small? In Agile, again, we have sprints that are, you know, development cycles that are 1 week, 2 week, 3 weeks, or 4 weeks. And we use user stories instead of requirements. Excuse me. And a small simply means that this user story or this requirement can be delivered inside of a sprint. So if we have, I like to work with 3-week sprints, so if we have a 3-week sprint and we're looking at the user story, I'm looking for the developers to tell me that they can deliver this story within 3 weeks. If they can, then it is small enough and we'll accept that user story. If they cannot develop it in 2 weeks, then we break it into 2 stories. That way it allows us to get our arms around it. It keeps it small. Small is manageable, and small is a lot easier to deliver. And then, of course, it has to be testable. Going back to estimable, the same example, easier to use as a requirement is not testable. Again, it may be easier for you to use, but it may not be easier for me to use. So, again, the acronym is INVEST. If you find yourself writing requirements, reading requirements, evaluating requirements, this is a great tool for you to use to make sure that these requirements are good requirements. And the whole piece of this is that if you have these attributes of your requirements, you will be able to easily write an acceptance criteria. Okay, so the definition of acceptance criteria is the criteria that the requirement owner will use to validate the requirement. In Agile, the requirement owner is the product owner. He's the one who's been authorized by the stakeholders to represent them to the development team. In a waterfall organization, the requirement owner will be the stakeholder. So they need to absolutely validate that the acceptance criteria, if that is met, that they will accept that criteria, or they will accept the requirement. So the book gave a great example on page 212, and the requirement is the system shall tune a radio channel within 3 seconds. The acceptance criteria, very simple. The correct channel starts playing within 3 seconds from selection of channel. Now, a few slides ago, I said that the function, the acceptance criteria will help clarify, will help validate some of the functional requirements, some of the aspects of it. And here's what I mean. So if you look at this requirement here, the system shall tune a radio channel within 3 seconds. Well, that could mean many things. That could mean that the channel is tuned in, but are you actually hearing something? You know, that's one of those things that the stakeholder would probably assume, yes, of course you will hear something, but to a developer that may not necessarily be the case, and maybe there is some nuance with the circuitry in this case, that once you tune a channel, that there's up to a second of time lapse before you actually hear anything come through that channel. But the acceptance criteria makes that very clear. the correct channel starts playing within 3 seconds from selection of the channel. So it's not just that there is a selection, but that the channel starts, playing, and that's a very clear clarification of that requirement. So the requirement and the acceptance criteria work best when they can work hand in hand. A well-written requirement makes it easy to write an acceptance criteria, and the acceptance criteria will help clarify any ambiguities that are in the functional requirement. Now, the acceptance criteria, if the acceptance criteria is difficult to write, then it's probably because the functional requirement or the user story is poorly written. And if you are having difficulty writing the acceptance criteria, go back to the invest criteria and see if you have achieved each one of those attributes of a well-written story. Most likely you have not, again, if the acceptance criteria is difficult to write. Okay, so here's here is a real live example from a project that I worked on, again using Agile. This is User Story 1301. The title of the story is Save Filters by User. You can see this is in Agile we use index cards. Well, this is a software system called Visual Studio, and this is Team Foundation Server. It's a Microsoft product intended for .NET development shops. And so this is just what we use instead of a real life. I think I showed you in previous chapters where you have this wall, we call it a wall board, and you actually put sticky notes up there. Well, that was ultimately I think that's the best way to do it when you come to Agile. But when you work on distributed teams, I was in Atlanta. Our clients were in Portland. We had developers all over the country, so we had to use something online. This is what we use, and this is our index card or our user story card. So here's the user story. As a Portico user, now this is the code name for the product. As a Portico user, I want to save the filter settings for my interactive filter so that I can reuse the same filter in the future with no more than 2 clicks. That is a very that is a very well written story, very clear. And just in case just in case there's any ambiguity, because there's always a few questions when you get into some of these things. And again, if I just take a little side diversion here, a user story is not the full definition of the requirement in Agile. In Agile, the user story is a placeholder for a conversation. So it's very light, and it means that when the developer starts working on this, he or she is going to have a conversation with the product owner. Well, in our case, the product owner, it's hard when you're distributed to have those conversations. So the product owner and the architect anticipated what some of those questions would be, so they went ahead and provided some description down here. Now here, on this side, is the acceptance criteria. And we use in Agile, it's not all the time, but commonly you use this format, this template called given, when, then. Given a user, meaning a user is logged in, and they have another given statement. So given a user and a filter setting, when the user saves the filter, then the saved filter is available to be used in 2 clicks or less. So here's the situation. When a user is signed in and the user has created a filter setting, when the user saves the filter setting, or after the user saves the filter setting and then he comes back in, then the save filter is available to be used in 2 clicks or less. So that's very clear. When the developers are developing this and the testers are testing this, they understand that this is a precondition, and that when the user relogs back in, that filter setting that was established previously and is now saved is available in 2 clicks or less. So if the development team creates or provides this solution but does it in 3 clicks, then the product owner does not have to accept it. He can say rejected, go fix it. Now, there may be an opportunity for negotiation, because it could be that the architect comes back and says, listen, in order to deliver this in 2 clicks, it will require about 3 months worth of work. Just the way the system is architected, there's no way that we can provide this in 2 clicks. So if you want to add 3 months worth of work, then we can do it, but I just need to let you know that. So now the product owner might say, oh, 3 clicks, that's fine. Or he might say, absolutely, I've got to have it in 2 clicks. I don't care if it takes a year, we've got to have 2 clicks. So there's that room for negotiation, and that's one of the key attributes of Agile. Again, I know you guys are probably tired of hearing me send plugs for Agile, but it helps provide some of the context here. All right, so that's the user story, or the acceptance criteria, what it looks like in a real-life scenario. So the bottom line for acceptance criteria is make sure that the requirement and acceptance criteria can be measured by a practical and affordable acceptance procedure. Now, something you need to be careful about is if it takes $1,000 to write the code, but $10,000 to test it, you got a problem, and you don't want to do things that way. So when you develop the acceptance criteria, it's good to have your testing team, or at least your test lead, to come in and just glance at the acceptance criteria and make you aware of those kind of things. And it also goes back to the INVEST criteria for writing good stories. It's got to be testable. Yes, it might be testable, but if it costs 10 times more to test it than it does to write it, yes, it's technically testable, but it's not very smart to do it that way. So you need to find a new way to test it. The other bottom line here, make sure that achieving the measured value delivers what the stakeholder asked for. Now, let me go back to our test case, or our user story here. The product owner, in this case, the product owner wrote this statement. The product owner also wrote this statement. So it's not like he wrote this statement and then someone else derived what the product owner wanted. The product owner wrote both statements. If you don't have a product owner and you're dealing directly with stakeholders, they're probably not skilled enough to write good INVEST stories and write good acceptance criteria, but you need to have the stakeholder validate the acceptance criteria that it will meet his needs. So if you don't have that, then you cannot move forward, because you're putting your time and you're putting the project at risk that the acceptance criteria is not going to meet the need of the stakeholder, which is what this is identifying down here in this second bullet. Okay, so there are a couple of verification methods or testing methods, making sure that you're delivering or you're getting what you're asking for. And types of method are in test. There's push button testing, which is automation, and you see this most likely in regression testing. So you've developed a lot of functionality, and every time you add to it, you add another requirement or another piece of code to it, you have to test the whole thing, or at least test those areas where that new code is touching. And that's called regression testing. It means you're testing the stuff you've already developed to make sure that it's not broken. For the most part, we have this thing called regression testing, which is automated, and it makes it very easy, so you don't have to go back and manually test those things, because once you get a very large and complex product, manually testing is time-consuming and very, very expensive. Then there is also this thing called certificate. Now your book says that this is a verification method. I would not say it's a verification metric. It is a metric instead of a method, because basically we're creating something. We're creating code to a standard that we've already previously agreed upon. Now that's really more of a technical standard that has very little to do with delivering the value to the business. So that's why I call it a metric rather than a method down here. Demonstration. Again, this is something we do in Agile, and demonstration is showing the stakeholder what you have so far. It may be that like I said, in Agile, things are very light. We try to document as little as possible. We try to focus more on those conversations and pulling the customer in, bringing the customer close to the development so that they can periodically, every 2 or 3 weeks, come in and see what we've done and give us feedback and tell us, yes, it's what I need, or no, it's not, and here's what we need to do differently going forward. Inspection. Now this can be a code review. So there are times when it's very difficult to test, like we talked about earlier. If it takes $1,000 to develop it and $10,000 to test it, you got to come up with a better way. Well, sometimes we do that by having a having a code review, meaning that the developer brings his code to the team, which would include, the other developers, the other testers, and the architect, so that they can look at the code and evaluate if it's going to do what it says it will do. Then you have analysis and simulation. This is really the end-to-end testing. Oftentimes we use dummy data. It's kind of related to demonstration, just making sure that everything flows through correctly. And all this, keep in mind, is once we have a requirement and once we know what the acceptance criteria is and we know what value we're delivering, this end-to-end testing will be able to verify that. Now, before we finish up Chapter 9, I need to say something here about testing, because in the passing of requirements from the stakeholders to the developers and ultimately to the testing, things can get lost, things can fall through the cracks. So in typical testing, this first scenario, the typical testing scenario which is not integrated, what happens is the developer reads the requirements and then codes. Then the tester also reads the requirements and creates a test case. The developer finishes the code, he unit tests the code and sends it to the tester saying it's ready to be tested. The tester will test the code according to his test cases and he will find defects. Now that all sounds, well, that's pretty basic, I understand. There's this methodology called test-driven development. Now this is a part of an Agile methodology. Now I'll take a little diversion here. In Agile, there are about, I think my last count, there were 17 different Agile methodologies. For example, Scrum is an Agile methodology. Kanban is an Agile methodology. There's another one called XP, which stands for Extreme Programming, and test-driven development is a methodology, is a tool inside of XP, which is again an Agile methodology, but oftentimes these are all interchangeable, so we do pull test-driven development into Scrum quite often. So it works like this. The developer reads the requirements and writes the test case first. Then the developer writes the code and sends the test case and the code to the tester. The tester then tests the code, validates that it passes, performs regression tests, and it has a very high success rate. So it almost sounds a little bit like cheating. If the developer gets to write the test case first and then he gets to code, well, you know, it almost sounds like there's a little room to, produce less than what is being requested. Keep in mind, if the requirement is clear and the criteria, the acceptance criteria is clear, then this is exactly what you want. You want the developer delivering the minimal marketable feature in order to do the job. So it's a lot like, I think you guys asked me about 2 weeks ago, you said, do you have a study guide for the test? And I told you, well, you've got the whole book. Well, you were thinking more like an agilist. You said, well, just tell me what I need to study for, and then because I know your intent, I'll study only that, and I won't study the other stuff. Well, that's kind of what they're doing here. The developer gets to say, I know exactly what the test case is. I know exactly what has to be developed in order to pass the test case. Therefore, I'm just going to work on that piece. And that's great. That's exactly what you want. Don't work on anything that you don't need to. So that is test-driven development. It takes a little bit longer, but because you have a lot fewer bugs, it actually takes a lesser amount of time in the long run to do test-driven development. Okay, that is it for Chapter 9, and we do have an intermission. So going into Chapter 10, before we get there, I've got a video, about a 5-minute video for you to watch. Now, if you remember, we talked a couple chapters ago about this thing called prototyping. And prototyping is really just, if a picture is worth 1,000 words, then, let's draw pictures so we can speak to many words. So prototyping has come a long way from, drawing things on a whiteboard to having some SketchUp software to a tool that we're about ready to see. But the reason I like this, so here's the thing. You're going to look at this and say, wow, everything you've been teaching us is, according to this guy, is debunked. Everything is wrong. That's not necessarily true. What we're learning here is the fundamentals of requirements for software development. And it is a great place to start. It certainly would not be the place where, and albeit the text and the material we're covering now, the book anyway, really focuses on a waterfall shop. Again, it's a great place to start. It's a good foundation to have. It's not necessarily the best way to do things, but it gets you to the fundamentals of how we create, how we discover requirements in order to build software. But I like the process that this guy goes through, because he really he identifies a lot of the things that can go wrong with requirements. And with, it's not necessarily requirements as much as it is people, because we have this fault of ours to let things fall through the cracks, that despite how hard we try, we understand things in different ways. We use words to depict meanings, but those words can be misunderstood. This guy captures it very succinctly, and he provides a solution that is this prototyping tool. So anyway, about 5 minutes. Watch it, and then the video will just continue right into Chapter 10. And if you need to take a break, just be mindful of the time that we need to be back to the class, so that we can go through the exam material and anything else that you have. Okay.
So a company needs to build a large web application, say something like an online banking app. What do? Well, they get in a conference room, and a business analyst interviews future users of the yet-to-be-built application and finds out what they want and what they need. And he gets information. A lot of information. They explain what they want and what they don't want, what they think they need and what they think they don't need, what they don't want to see and what it should look like. And all that information is put into what's called a requirements document. And it's massive. Then a business analyst meets with the suits that run the business and finds out what they want and need. And he gets a whole lot more information. And all of that information is added to the requirements document. Now, once the final version of this document is complete, it's passed back and forth between the analysts and the business execs and the users while they collectively try to figure out if what's in it is the right thing to build. And while this is happening, each is making their own additions and subtractions. And all of these changes are incorporated back into that massive requirements document, making it nearly impossible to track and understand. And what is the root of the problem? Text is ambiguous. Two words can mean drastically different things to two different people. Now, if just two words can be interpreted so differently, imagine 10,000. So the business gets together and decides, based on the requirements document, how much money and time to put toward building the application. So once everything is signed off on, they give the requirements document over to the IT department, along with a whole lot of time and money. And it's their job to decipher the document and build the application contained within. So many months and dollars later, the business has their new web application. So they take their newly built app back to the users to see what they think. And guess what? They hate it. Why? Because the business analyst misinterpreted some of what they asked for. The IT department misinterpreted some of what the business analyst asked for. Things they thought they wanted, they really don't need, and a bunch of stuff they do need is missing because they didn't know to ask for it, because they didn't know they'd need those things until they had a chance to use the application and find out. And by the way, someone forgot to include a submit button on the change password form. So now the business has to go back and figure out how much more time and money to spend fixing the application. So why did this all happen? Because text is ambiguous, and that huge document is nearly impossible to understand. And if the user can't picture the application, they can't understand it and give accurate feedback. What they need is a way to test drive the application before it's been built. Can you imagine giving feedback on a car before you've driven it? Until you wrapped your hands around the steering wheel and felt how it handled around the turns? Until you know how well the brakes work? Or if they work at all? The reality is, this is a horrible way to define business applications. As is this, and this, and this, or any combination in between. Now, this static screenshot might look better, but the fact is it's flat and non-interactive. You might as well remove all functionality completely because it tells you nothing about how the application will perform. And if the user can't interact with it, it's virtually useless. Now, what if that business analyst had a tool that allowed him to easily create a mirror of the final application before a dime was spent building it? The user could log in and view their account just as they would the final application. They could interact with it and get a feel for how it would perform. They could see how the branch locations page would work, along with all functionality connected to it. And for those users dispersed around the world, what if you could email a version to them which they could test out and add their feedback? And they could even tie feedback to a specific item on the page. And once finished, they're all sent back and imported to the central server. What if there was already an application that was revolutionizing the way applications were built? There is.
Okay, welcome back from the intermission of the video. And so as you see, the video kind of debunked everything that we're trying to learn here. And as I said before the video, it's not. I just want to point out some of the problems that are experienced when you create these massive documents called requirements, and then you expect to produce a perfect piece of software out of it. And when I say perfect, I don't mean it without bugs. I mean it's something that the customer is going to say, yep, that's what I wanted. And that oftentimes, actually more often than not, the waterfall approach to building these requirements and then ultimately developing off of them and getting it back to the customer, more often than not, it's not what they want. Yeah, I mean, there's some parts that they want, but I think they said about 62%. I could be off on that number. Said no, it's really not what we were looking for. We wanted something different, and that's the problem. That when you take these all-important conversations and collaboration between customer and developer, and you relegate it to written documents, yes, of course, a lot of things are going to be lost when you do that. But as I said, this is a good way for us to build the building blocks of understanding what it is, what's involved in discovering requirements, and how to do it very well and miss some of the common pitfalls. All right, so Chapter 10 is about priorities and identifying and prioritizing the requirements. So really what we want to answer are which requirements will we decide to deliver given that we do not have enough time or money to do all of them. And what is triage and how do we do it? So rarely have I seen a project where they have enough time and money to do every single requirement. From obviously you do the most important ones, but even all the little bitty ones, do we really have enough time and money to do all those as well? So when we talk about priorities, there are the input priorities, and these are the requirements basically of what the stakeholder wants. These have to be prioritized going into it so you have a good idea of what you're going to be working on. And given all the requirements that have been discovered, how do we prioritize them? Now, then you go through this exercise that the book calls these output priorities. Basically it's going through that process of saying, given the restrictions that you've placed on us, being time or money, what can we deliver before we run out of time, and what can we deliver before we run out of money? In waterfall, or traditional, I don't like to call it waterfall all the time because things have evolved. In traditional software development, there's really a better term. We had this thing called the magic triangle, made up of time, quality, and functionality. And the way this works is the customer can pick any two. The customer can own any two of these items, but I get to own the third one. So for example, if the customer says, I want all the functionality in the requirements, and I want it all done, not in 6 months, but I want it done in 3 months, I own, guess what? I own the quality. And what kind of quality are they going to get? They're not going to get very good quality. If the customer says, listen, I want all the functionality and I want it to be just, out of this world quality, I own the time, and I can tell you that's going to take a long time. And the customer says, I don't have but 6 months to produce this, and you're telling me it's going to take 18 months. Well, you can reduce your quality or you can reduce your functionality, Mr. Customer, and that's how you can get this back into the time constraints. So all these are related. Another term to call it is they are sliders, but the customer can own two. And this is something you need to understand. If you're going to be leading projects, this is an expectation that you set up front, and you actually, when all the requirements are defined, when they are prioritized, then you sit down with the customer and you draw time, quality, and a triangle, and functionality, and a triangle on the board, and you say, okay, here's something we need to understand. And then you go through this exercise to explain, you get 2, I get 1, and we'll take it from there. It is impossible for the customer to own all 3 of these, because something invariably will go wrong. Things always go wrong, and it'll just lead into disaster, one after another. Okay, inputs to priority. Now these can be many things. If you're in the medical field, you're going to have HIPAA compliance. If you're going to be dealing with customer data, or in the financial field, you're going to be dealing with Sarbanes-Oxley. Every corporation have their corporate drivers, which places importance on some things over others. You're going to get expert advice, industry advice. You're going to get a lot of advice from your architects, especially when it comes to dependencies. There are voting workshops among your stakeholders. And then there's this thing called the benevolent dictator, and we'll get to that in just a little while. Now, in Agile, I always say that there are 3 things that create priority. The first one is value, the second one is dependency, and the third one is risk. In Agile, again, if you remember, basically all the priorities, or all the user stories, the requirements, are stacked ranks. So if you're looking at a list on a piece of paper, the most important user story, the most important requirement, is on top of the list, and that's what we're going to work on first. Then the next one down, we'll work on that because that's the next in importance, and we'll just continue on down the list, just working through them as they are prioritized. So the first thing we want to say is the most important thing on the list is the one that is the most valuable to the customer, to the company, the one that brings the most value. Now, that is also influenced by dependencies, because certainly we don't want to spend all of our time working on a user story or a piece of functionality that we can't deliver because we've got to wait for 3 more sprints for something to be delivered. For example, there's a piece of code that we want to deliver or we want to build because it's the most important thing, it's top of the list, but it requires an API or an interface with the billing system. But the billing system can't provide that because they've got a backlog and they're not going to be able to get to it for 3 months. Well, we don't want to build this functionality only to sit it on the shelf to wait 3 months for this API to be built. So you might ask, why do we not want to do that? Well, the reason is because things change. Requirements, if you take that piece of code and you build it, you can't test it entirely. You can't, at least you can't do a end-to-end or integration test on it. Because you don't have that interface built. If you go and set it on the shelf, when you come back to it 3 months later, you're going to have to do this thing called context shifting. You're going to have to get your head back into that code and kind of figure out where you were and what was going on, and maybe go back and talk to the customer again. And that is all taking time to do that, and time's valuable in software development. Also, it could be, if you're waiting 3 months, the developer has left, and now another developer has to come in and either has to work his way through understanding that, and it's just messy when you do that. Also, the requirements may change. It may be that in that 3 months period of time, something with that interface has changed, and it would also then cause changes in the functionality. So enough about that. Then also risk, and in risk, the reason it drives drives priority, because risk is defined as risk because it is an unknown. There's something there that we don't know. And if we don't know what it is. We don't know how long it's going to take. We don't know what kind of resources are involved. We don't want to save that kind of stuff for the end. We want to get on it right away, because if it is going to impact requirements down the line, we need to know that. And if it's going to take a long time to work through it, we want to deal with it now and not at the end of the project. So these are my three. When I get into a project with people, it's value, business value is one, risk, and dependencies, architectural dependencies. All right, so let's talk about voting. Voting is probably the most common way to prioritize requirements in traditional software management. The requirements at this point really should have been prioritized already. When you come up with a requirement, it's a good idea to say, how important is this? And usually the stakeholder will tell you, give you an idea. But in light of the total project, once you wrap in all the requirements, the priorities may change. So it's good to go back and review this. Now, there are a lot of voting methods. Some are better than others, but as long as they all work, then you can use it. You've got some mandatory, desirable, possibly useful, and luxury. I think I've seen probably one that I've seen more that is like this, but is required, nice to have, or required, should have, nice to have, and in a pipe dream. Then there is monopoly money. So I've seen where we've taken a spreadsheet, we put all the requirements on the spreadsheet. You gave each stakeholder in the room in a workshop environment and said, okay, you've got X number of dollars to spend on these requirements. You go ahead and put your money on what's most important to you, and you collect all these together. You aggregate them, and you'll get a pretty good idea of what's most important to the organization. That's good, and that's really good when you have a lot of stakeholders, and especially when you don't want to get into a workshop where they're going to argue with what's more important. Everybody in a system like this, everybody gets their say on what's important to them. In Agile, we use point cards, so basically everybody says, hey, this is an 8, this is a 13, this is a 5, and then we will ultimately get to the point where we keep voting and keep voting and keep voting on the requirement until we come up with a consensus. And then there is probably the one that I've used. Well, in Agile we use point cards, but when I was doing traditional software project management, I like to use just high, medium, and low. And the reason I like this is because when you take something like this up here at the top, mandatory, desirable, possibly useful, luxury, what you're doing is you are subverting a judgment on these requirements. Now, maybe not so here. I think everybody understands mandatory means required. But you take a word like luxury, especially when you talk about, in a cost-conscious organization, a luxury may be a bad thing, and you don't want this. A requirement is a requirement. It's not necessarily good or bad. It's just a requirement. It's either more important or less important. That's really what we want to discover. So we don't want to taint it with language like this. I don't like that. So what I like to do is just quickly go through requirements and get people to say, hey, just this is high, medium, or low. You tell me. Go through this requirement. They say, oh, it's a medium. 5 people say it's a medium, 3 say it's a low, 1 says it's a high. You just say, hey, can we just agree that it's a medium? So what happens at the end of that, you'll have a big list of highs, a big list of mediums, and a big list of lows, and then you go through all the highs and you stack rank them. You say, okay, what is the most important high on here? And if you need to go through another round because you have so many requirements of saying, okay, this high is a high number 1 and this is a high number 2, this is a high number 1 and this is, you go through and you stack rank those. It just makes it more manageable. And then you get the entire list from top to bottom organized and stacked rank from 1 down to however many requirements you have. Then you let the stakeholders, soak it in. And if they say, I really believe that this requirement at number 89 is much more important than number 46, so we need to move it up. That's okay. You want to have those conversations. Okay, the benevolent dictator. So you've probably heard somewhere back in high school or grade school that the best leader, when you're talking about leaders, it's probably maybe back in world history, the best leader is what they call the benevolent dictator. Someone who loves his people, takes care, is selfless, just doesn't keep anything for himself. He's not a tyrant. He loves his people and takes care of them. Well, this is kind of what we do with when we talk about the product owner. And as far as priority, it makes life really easy on the team. The product owner is the single source of requirements that the development team needs to deal with. So now you've got the product owner in the middle, you've got the development team to his left, you've got the stakeholders to the right. In true agile fashion, the stakeholders have empowered the product owner to represent them. That's a perfect situation to be in. That's why when you take a product owner, it's really not someone who is a business analyst per se. A product owner really understands the domain space, understands the product, understands the direction of the company, and they are empowered then to make these kind of decisions. The product owner's greatest power on the team is setting a priority and defining when work is complete. So they're the ones who say, this is what you need to work on. Here's the user story. This is when you need to work on it, and here is what it needs to do when you're done with it, the acceptance criteria. That's the benevolent dictator. So when we talk about priority, this is the best situation to be in as far as avoiding the conflict that is sometimes associated with priorities. Okay, so going back to a project that I worked on, this is the same one that I've showed you earlier. Just kind of want to talk through how we set priorities in Agile. Real life example on a product that I worked for, this company up in Portland, and this is something I put together to help describe to the team our process of how we're going to build the product backlog. The product backlog is that prioritized list of user stories, and how we go about doing that. And it's dynamic and systematic. We do it basically every wave. Sometimes they call this a release. This company like to call it a wave. You've got the sprints here, and this is what they would do. They would start out, the product owner identifies the valuable stories for next release. So all along he's been collecting all these stories that need to be done, all these requirements. And the product owner and the lead architect, they analyze the stories, creating system stories and story point estimates. So just the two of them. And what's happening in this process is the product owner is identifying the business value. He says, this is most important to the business, these set of requirements. These are the ones I want to work on. He discusses that with the lead architect to understand risks and dependencies. That's why, and this is a 3-week period of time that they go through this, an hour here, hour there, doing some research, coming back together, continuing to chew on this. Finally, coming out of that is the product owner will begin to sequence the stories into the next 3 sprints. And that takes about a week and a half to 2 weeks. And then the certified Scrum Master, that was me, and the product manager would perform a sanity check just to make sure, again, we talk about things like resources, talk about timelines, make sure that everything is doable. And then the product owner reviews the desired stories with the team, and the team will then select the stories for sprint 4, which is the next sprint in this case. The product owner and developer, they meet and confirm the estimates that the team just gave, and then they go through task planning and sprint 4 planning. This section here, steps 5 through 9, would happen at the preceding every sprint. So this is just a one very typical way in Agile that we would go through this process of prioritizing the stories, and again using that product owner or benevolent dictator to understand this and to go through that. All right, now the book also talked about output priority, and this is defining, what can we work on given, we know what the business wants us to do, but what can we realistically work on given the constraints that have been placed on us, being time and money. Now, in traditional software project management, what happens is at the beginning, like the video showed, at the beginning of the project, once all the requirements are captured, then an estimate is given by development, and they'll come back and say, this is going to cost $800,000 and will take us about 7 months to do it. Okay, so there's your estimate, there's your time, and there's your money. And then they have to confirm that they can do all that. Well, in Agile, what we do is we say we've got 3 weeks worth of time, and we need to understand what we can do in 3 weeks worth of time. So this is again another real life example of what this is what we called our code delivery schedule, and everything. We work on these in priority order, starting from the top. So these are the most important. These 2 bugs are the most important things we need to work on, and then we work on this next item, UI download attachment, and just continue working on these things. And we already have agreement from everybody on the team of when this stuff will get delivered and dates. Now these are dates within the 3-week period of time, so we're just dealing with very small chunks. We know exactly how much. We don't really have to spend time estimating how long this data layer integrate transactions and unit of work. We don't really need to estimate how long that's going to take per se, to understand how it's going to fit. All we have to really understand is, can we do it in the sprint? Because we know how long a sprint is. We know our time. We know our money. All we have to do is, can we fit it into the sprint? And the team reviewed with, let me go back to this one, the team select the stories for the sprint. The team knows what it can do, and they will actually, so here's the product owner says, here's all the things I'd like to do. The team will say, well, this is all we can do in the next 3-week sprint, and this is everything that they can do. Now there's another form of output, and as far as calling this output priority, I think this must be a UK term. I don't hear it much here in the States. Calling it output priority, it's just a process of identifying what can be done and when it can be done, more according to a scheduling process. But there is a output priority that is in addition to what the book has said, and that's dealing with your bugs, because the output of developing code is going to be working functionality, but also you're going to have bugs. It's inevitable. No matter how good your teams are, you're going to have some sort of bugs somewhere, somehow. And this is just the front page document of a triage process that we came up with. Basically, you need, when you have a bug, you need to understand how you're going to handle it, how you're going to triage it. Triage is taking, I believe it's a French word, taken, from the emergency room process of when the battle wounded come in. You need to identify how, what priority you're going to work on people. So as you see, with the bugs being an output of your development, you see here we have placed these bugs on top. These are the most important things. So these were bugs that occurred in our last sprint, and we have placed them as our #1 priority in the next sprint. We did that just because that's the process that we developed inside of our Agile team. So our triage process looks like this. Starting with the tester. The tester discovers a defect. He opens a bug, and then it goes to the developer. That developer will estimate the bug. If the bug takes less than 30 minutes, then he fixes the bug and it gets retested. If he estimates that it'll take more than 30 minutes, and this is really just a 2-minute decision, then he sends it back to the product owner, and who in this case was Tom, and Tom would prioritize and review the bug, and he would prioritize it into the next sprint. And then it would get fixed as a priority in the next sprint and then retested. So that is another output or an output priority that needs to be considered, because it becomes an input into your next series of development. All right, so that's it for Chapter 10. Now let's talk a little bit about Exam 2, which will be Chapters 6 through 10. And you are responsible for all of Chapters 6, 7, and 8, all the chapter, that is. Chapter 9, you're responsible for pages 223 through 232. Chapter 10, pages 236 to 241. The test will be 50 questions. Half of the questions will come from the book, half will come from the class presentations. You'll have 2.5 hours to complete the test, and which equates to 3 minutes per question. All right, that is it. I will see you after the break when we rejoin on Illuminate.